Alright, so here for number 1 of paper 2, we have that the cities Lucknow in L, okay, and Jaipur in J and Delhi in D are represented in the following diagram. Lucknow lies 500 kilometers directly east, okay, this is more important than what we think, directly east of Jaipur, and JLD is 25 degrees, which is this angle right here. They also tell us, and this is interesting because it does not show up in our diagram, so always double check for this kind of stuff. They also tell us that the bearing of D from J is 34 degrees. Now, before we jump into part A and part B, let's first understand what the bearing even means. The bearing, ladies and gentlemen, will always be thought of from north. Okay, so if you have a random point here, let's call it A, okay, and they say, you travel 10 meters, or well, it's in kilometers, so let's say you travel 10 kilometers at a bearing of whatever, 150, degrees, right? And so what you're going to do if they tell you something like this is that first, you identify that you start by looking north. Okay, that's why you put an arrow straight up. You start by looking north and you count your degrees until you reach 150. Now, 150, let's remember that a straight line is 180, right? And so if a straight line is 180, that means that's going all the way to the right. Okay, it's just going to be 90 degrees, right? So I'm going to do first 90 degrees and then a little less than a straight line, so it's going to be around here for 150 degrees, okay? And so in order to express that you travel 10 kilometers at a bearing of 150, you would be drawing this purple line, and you would be writing here 10 kilometers, and you end up here, right? And so this line up north is just for us to understand how bearing works. But now that you wrote it, you can just erase this. You can put that 150 just so that we remember, right? But technically you started here, you ended up there. That is what the bearing of 150 degrees is telling you. And so the interesting part here is that because they give us in red that the bearing of D from J is 34 degrees, that means that, oh, look at that. You have a line going up north. And so this line going up north, you have to count the degrees until you reach 34, and that's going to be the bearing from D to J. So in other words, the angle right here, ladies and gentlemen, is 34. And so now that we understand what bearing means, we can now put it in our diagram, and suddenly part A becomes a lot easier. And so part A, it is find JDL with D having a little bit of a hat. Now when it has that little hat right there, it is asking for the angle, okay? So basically it's like angle D, but in respects to J and L, because it's between J and L. And so it's the angle D that is right here. Okay, so that is what they're asking for part A. And the IB, if there's one thing that's nice about it, there's not a lot of things that are nice, but the one thing that is nice about IB math is that if they give you something, you have to use it. And so this bearing that they gave us, why is this such a big hint? It's a very big hint because this angle here that you found of 34 combined with the information that, yo, Lucknow lies directly east of Jaipur means that this line that I'm putting in purple is a straight line. And so if you have a straight line over here and a straight line going north, that means this whole thing is 90 degrees. But if this whole thing is 90 degrees and this sliver in red is 34, then what's inside is going to be, you guessed it, it's going to be 90 minus that 34. And so what's inside is 56 as shown by my calculator. Remember, for paper 2, you can use your calculator, okay? And so over here, we end up with 56 degrees, right? And so now the triangle that you're trying to handle, right, is basically one that goes like this. Let me use a different color. It's one that goes D, L, and J. You know that this is 56. You know that this is 25. And you know that the angles inside a triangle add up to 180. So 180 is going to equal your angle for x. So it's going to be x plus 56 plus 25 degrees. And so if you want to leave x alone, you can do minus 56 and minus 25 to both sides. So it's basically just going to be 180 minus those two. So you can do 180 minus 56 minus 25. It gives you 99. And so bada bim, bada boom. For part A, you can just say that angle JDL has to equal 99 degrees. And now for part B, okay, and now for part B, you need to find the distance between Lucknow and Delhi. And so the distance between Lucknow and Delhi in this triangle, blah, 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 I can't speak. The distance between Lucknow and Delhi is going to be this line here. And so going back to the diagram I did down here, you need to find the distance from here to here. Now, take a close look at this triangle. What do you know about this triangle? This triangle specifically, you just found out all three angles, right? And so let's take a moment and think about it. In a triangle, you have three sides and three angles. Right now, I have three angles and one side. And so immediately, you got to be thinking about the following thing. You are dealing with a triangle. And so the tools that you have in respect to a triangle, well, one of the main tools that you have is what we call trigonometry. Now, guys, I need you, trigonometry, I need you to identify the following procedure. Okay, the main special thing I like to bring to the table when I make these videos is really talking about procedure. So the moment you realize you're facing a trigonometry problem, specifically of a triangle, duh, right? And you need to find a missing side or a missing angle or whatever, the approach I need you to employ is first going to be try the sine rule, and then it's going to be try the cosine rule, okay? And if you can't use either of these, then you probably need more information, finding it somehow, etc. Find the missing side, and then try the sine rule, and then try the cosine rule, okay? But point is, why do you follow this process? You follow this process because if you go to the formula booklet, okay, very important to get familiar with it because it is an additional tool the day of the test. If you go to the formula booklet and you go all the way over to trigonometry, which seems to be topic 3, all right, so page 6 and 7, blah, blah, blah. Here you have the main tools for trigonometry. You have these three, okay, you have sine rule, cosine rule, and area of a triangle. Now, why do I suggest first sine rule and then cosine rule? It's not only because sine rule shows up first, it's also because sine rule, you can see, works in pairs, okay? While cosine rule is usually like one missing side, like only one, or one missing angle, okay? And this is how I just want you to memorize it sort of intuitively. Sine rule is going to be for pairs, and cosine rule is like one missing side or one missing angle. Now, I know that some of you might be looking at this formula and thinking, what the heck is this even saying? So let's establish something, okay? The little letters and the big letters have to do with angles and sides. So, memorize this diagram I'm doing over here. Imagine you have a triangle that has points A, B, and C, okay? So, the angles, ladies and gentlemen, are going to be the big letters. So this is angle A, this is angle C, this is angle B. And what is the side associated to angle A? Well, it's the one all the way on the other side. So the angle associated to big A is little a. The angle associated to big B, the side associated to big B is little b, and so on and so forth. And so once you have that in mind, using these tools is much easier. And so now that we established that the little letters are going to be sides, while the big letters are going to be angles, okay, whoops, not those big letters, sorry. These big letters are going to be angles. Then the sine rule becomes a lot more friendly. Because first of all, there's equal signs here and here. So that means you can combine it, like this, like A with B, or you can combine it like this, A with C, or you can combine it like this, B with C. So that already gives a lot of sort of flexibility, see? And the other thing you can sort of establish is that instead of little a equals little b and divided by this or that and blah, 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 what this is really saying is that, yo, the little letters are sides, right? And so technically the sine rule, what it boils down to is that side 1 divided by angle 1 equals side 2 divided by angle 2. Now, important detail that you have to keep in mind, these angles have a sine next to them, right? But technically, all it really is, the sine rule, because it works in pairs, is that you have the side of the first one with its corresponding angle equaling the side of the second one with its corresponding angle. Okay? That is what it really boils down to. And so why is it important to think about it this way? Because for part B, if you need to find the distance between Lucknow and Delhi, well, think about it. Do you have at least one pair? Yes, you do have one pair because you have this angle associated to that side. And so suddenly, that's going to be your side 1 and angle 1. And on the other hand, if you're trying to find the thing that is in green, well, what is associated to this distance in green? This angle here. And so, the moment you have one pair, in the sense of angle and side, sine rule probably works. Okay, so side 1 divided by angle 1 with sine, right, using the sine rule, it's going to be side 1 is 500 divided by sine 99, right, equals the side that you're trying to find, which is the distance between Lucknow and Delhi, which we will call x, okay? So that whole thing is x. X divided by sine 56. And so, boom, once you understand the formal booklet, once you understand sine rule, this exercise is actually extremely easy, okay? So I just wanted to take a moment, really explain like what sine rule is, how it works, what the letters mean. And now you understood the procedure for triangles and trigonometry. Always try sine rule. If that doesn't work, go to cosine rule. I'm not going to show in depth the cosine rule because this exercise doesn't need it, but I will give you the hint that notice there's two versions of the same formula. In one of them, you have a side that is alone, and on the other one, you have an angle that is alone. Okay? So if you're trying to find one missing side and you have its angle, you can use this one. Or if you're trying to find one missing angle and you have all the sides, you can use this one. All right? So yeah, that's just a quick hint on how all of this works. See? And actually, once you understand all of that, the last hint I'm going to give you is that for the area of a triangle, all this really is, yo, you need one angle and the sides next to it. So, well, you can probably check another one of my videos where I use this area of a triangle formula or cosine rule, but at least I wanted to give you the hint of how little a, big A, and all that stuff works so that you actually understand these formulas and you can actually use them yourself. So, enough blah blah, let's actually solve the problem that is at hand. We can do cross multiply in order to get x alone. So you end up with x times sine 99 is going to equal 500 times sine 56. Now technically you can immediately get x alone, so you can, for example, divide by sine 99 to both sides. Sine 99 is just a number, so, well, this goes away with this. And so x is going to equal whatever this thing on the right is, okay? And I know it looks nasty, I know it's not exactly friendly, but trust the process. You use the sine rule, you got x alone, plug all of this into your calculator, and it should look something like this. Now, on the one hand, you want to make sure that your calculator, its mode, has to be in degrees, okay? You can leave your answer in radians, but all these angles are in degrees, so I'm going to do it in degrees, okay? And secondly, because you have a fraction on the right side, you can actually put a fraction in yourself using alpha y equals, and then pressing the first one. So this gives you a nice fraction. It can be a lot easier to plug in whatever you need to plug in. And so once we plug in whatever we need to plug in, you end up with 419.685. So for part B, the distance is 419.685. Now, I suggest, and this is just a general tip that I give, put the whole number. Okay, put the whole number, like the entire number, so that you don't worry about significant figures. If you want to answer in significant figures, you're going to count 1, 2, 3, and ask yourself, do you round it up or down? You round it up because of the 6, so you actually end up with our favorite number, 420. Don't forget the units, kilometers. So, ladies and gentlemen, just so you believe me, here is the mark scheme, and it looks pretty correct to me. So 420 and 99 degrees, that is for number one. And the most important thing is understanding when and why to use the sine rule. Okay, so you face a triangle, you consider trigonometry, first try sine rule, then do the other weird stuff. Okay? And how can you spot the sine rule more easily? Make sure you associate the sine rule to pairs. That is the best hint I can give you, and I hope it helped.